My name is Sarah Parsons, and I came to Wake Forest for the first time in 2012 to pursue my bachelor's degree. I graduated in 2016 after studying physics and mathematics. I then returned to Wake to be a double DEAC to pursue my master's in computer science, from which I graduated in 2020. After graduating, I served as a senior analyst on the analytics and data governance team in information systems, as well as a research analyst in the computer science department for Dr. Natalia Khoury. My research spans across several areas. First, I am interested in data evaluation and machine learning. The applications of this are, in my case, I have been looking at fitness tracking devices, as well as drug transporter data. And what data evaluation does is it allows you to evaluate your data sets and determine which data points from your data set are most valuable. And this is important when you run into really large, voluminous data sets and you only want to look at a certain subset so that you can improve your performance time, or when you run into sparse data sets and you don't have very much data, but you want to capitalize on the data that you have. Another area that is very near and dear to my heart is natural language processing, specifically topic modeling of computer science education research. So I focus on meta research, which is research about research. And using NLP, I am able to derive topics from computer science education abstracts to better understand the pedagogy of computer science and what is being taught, as well as what's important in the pedagogy of computer science. And I'm very interested in ethics, and so I have done quite a lot of research looking at computer science education abstracts focused on ethics. And why this is important is because as an instructor in the computer science department, I want to better prepare my students for the real world whenever they encounter ethical dilemmas, so that they understand the implications of their decisions and they can make the best decisions for the general public. For my research, I typically write my code in Python and then run my scripts on the cluster using the GPU nodes. For data evaluation, specifically, I use a package called Shapely, which consists of truncated Monte Carlo simulations so that we can take a subset of our data set and then run a model against it to understand how it performs on that subset. And by doing so, by running multiple permutations of different subsets, we can then identify which subsets of the data are most important. For my natural language processing research, I use two different algorithms. The first is latent dirichlet allocation, or LDA. The second is dynamic topic modeling, or DTM. And by using these algorithms, I can perform topic modeling on my computer science education abstracts and then derive topics so that I can better understand what's being done in the literature. And then I can share that with the scientific community in the manuscripts that I publish. For our research, we use large data sets, which require us to partition these data sets when running our scripts against them. And because they're so large, we're not able to store them on our local machine, let alone run our scripts against them. Fortunately, with the DEAC Cluster, we can store our large data sets and run our scripts. And the added benefit of using the cluster is that I'm able to partition my data and parallelize my scripts so that I can run my scripts faster and more efficiently. The HPC team has helped me install quite a complex package, TensorFlow, for some of my research, and because I needed a certain version, I wasn't quite sure how to install it on my local machine, and I was in the process of trying to implement this deep CRISPR model on the cluster. And so I reached out to Cody Stevens, our in-house expert in the computer science department, and he was able to install this package for me and for our lab group so that we could use this model in the future. So so thankful to the HPC team for their assistance with installing packages like the TensorFlow one. In addition, for a manuscript that I published recently with Dr. Corey, we needed to create a visualization, but also keep it anonymous as we submitted our paper for review. And using the data for topic modeling on the cluster, I was able to create a visualization and then reached out to Cody again for his help to actually host it on the cloud in AWS so that we could provide links to our reviewers when we submitted our manuscript, and that was great help. I look forward to continuing to work with the HPC team in the future whenever I run into issues like this in the future. Over the past year, my routine for research has changed quite a bit. Everything has pretty much gone virtual. My meetings are now all on Zoom. But despite all of these changes, my research itself has not changed much. Fortunately, with the HPC team up and running per usual, and me being able to use the cluster as I normally would, I have been able to complete all of my research just as I would have if things were not virtually. And I'm very thankful for the HPC team for being able to help me and troubleshoot a lot of my issues throughout the past year.